Okay, for people joining this live stream, this is going to be a fairly short meeting because I have to go about neural net design. And should we start off here?
Yeah. So it's mainly about NetFunction. And I think you validate most of the design last time. So you want a small recapitulation before we go to the last thing to validate?
Okay. I mean, basically, this is a compiler that goes to native MXNet code. Is that correct?
Close to our interface.
Okay.
So to our network language, let's say. Also, okay, so
it's a companion, we could say, to the compiler. It's
okay.
not really compiling the code.
Has anybody talked to Christopher about his efforts to design a new layer for the compiler?
No.
I think you should.
Okay.
I mean, I don't know what he's been working hard to basically put a layer on top of the compiler so that it's actually usable.
I see.
Right, so the intermediate code is usable, basically. Okay.
Okay. So the idea is that NetFunction would return a NetFunction. That's something that we believe is best. Like at some point we thought maybe it should return NetGraph. But the nice thing that returning a NetFunction is that you can still read the function. And we would like to have both. That you can both seize a graph and the function.
Well, how do you edit the code?
You'll have to read it. You have to recreate the NetFunction. I don't think we can. So you can convert it to a NetGraph by doing just NetGraph or NetChain, depending on what it is. And you can do NetExtract or NetTake, but this would go out of the NetFunction. This would return a NetGraph.
Right.
So addition, and honestly, addition of code is not super easy as addition of graph. I'm
sorry, what editing? You said addition. You mean what are you saying? Addition.
Modifying the function.
Yeah.
As an expression, it's going to be harder than modifying.
Okay, let me just understand what's going to happen here. So NetFunction, in principle, I can get this NetFunction, and then I can just say nettrain of this NetFunction. Is that correct?
Yes. So yeah, NetFunction works like any other network, any other layer, to be precise.
Okay, so what's the question here? So, I mean, there's a question of what can be in this NetFunction, and what does it do when you give it something that it can't have inside it?
Our idea is that it will be a compiled layer when it cannot go to our representation. Yes.
Okay.
So this, and
well, so okay, so that means that what you're suggesting is that the NetFunction. Okay, so I mean, you're going to get a summary blob from the NetFunction, and that summary blob, I mean, to me, it seems like you just need a button that says "Show me the code."
Yes, exactly.
It's NetFunction, and it's like in the summary blob, it's just a "Show me the code" button. And given that you can't really edit it, I mean, how do you get? Given that you have something that is output as a NetFunction, and you want to edit it. I mean, the input form of that net graph, if I'm not mistaken, is an editable thing, correct?
The input form, not really, no.
Well, how do I edit this? If I've just been
net extract, net replace, net extract, like you have specific.
No, but I don't want to do that. I want to just edit because you see, it's a different story here. Okay, that's no good. That's no good. That's no good. That's no good.
No, but you have a way. I mean, the point is this acts like graph. You cannot do that with graph as well.
Yes, you can.
With graph.
Well, graph itself, no, you cannot. Although you should be able to, but you can't right now. But this particular thing of not storing enough information, that's the same story.
No,
story has been.
Wait a minute.
Same story that has been the case. There is enough information there, but it says there isn't enough.
In that case, yes. In that case, yes, because you copied the output. No, sorry, you copied the visualization.
I understand that, but I'm saying that like data set, there should be a stripe down there that says, do you want to store this in the notebook? If
Definitely.
I just copied that, what's that?
Definitely, I agree, yeah.
Okay.
Classifier function does that, and we're going to put that to everyone.
Okay, all right, fine. Okay, so the issue here is, see, I think it's a different story because I think that very few people are going to want to edit raw net graphs. You know, I mean, how do I get back the net graph from this?
Net graph.
No. How do I get back an editable form of this net graph? Right, you're going to tell me I don't want it because the editable form of the net graph is full of weight matrices and all kinds of crud.
You can get sort of input form. Is it in net information or something that you can get input form of a net?
Yeah, but you won't have the weights.
No,
right,
no,
so it's not useful.
The structure.
Right. So my point is with okay, in both cases, both with NetFunction and with this, the untrained version is useful to get. But with NetFunction, people will seriously want the untrained version because they just wrote it as code. You see what I'm saying? And they'll want to tweak that code because mere mortals are expected to write net functions, whereas that's not the case with net graphs.
Well, if we return the net function head, that's not so complicated because you could store inside a string which contains the original code.
Exactly,
yeah, sure.
Exactly. We'll store the string and you will be able to extract the whole function for sure. In one way or another. It can be with net extract or it can also be with information.
Or it would be something where you could just like click a thing here, and just like we do with control equals, you just got the code there. And if you want to copy the code,
the same. You could edit it in place and in the output form, and then that would be revalidated. Like you just say okay, and it gets revalidated.
Well, hold on. That doesn't make sense. Look, what we should do is the same thing we do elsewhere. It's a we should not disable copy down. So if you put it in input, you click it into some form, you start editing, it will copy down the cell, and then you've got a piece of input again. And then the way that it would work is there would be code, there's basically a panel there that you can edit with code, and you change it, and it's an inputable thing again. Now, I don't know how common that will be, because I think the more common thing is people will go back to the source, the place where they got the source from in a source notebook and edit there. Maybe that's the right thing to do.
Yeah, I assume, but that's pretty cool that that's a good idea. We haven't thought about that you could modify inside the box.
Right, and just copy down. I mean, I'm not sure if that really works.
What do you mean by copy down, sorry?
Well, what I mean by copy down is something like this. If I say range of 10, and oops, my God. Okay, now I edit this, right? That copies down. Oh, yeah, it broke. No, this is copy down, right? It broke the connection. What is going on here? Yeah, okay, it made that into it made it into an input cell. I'm actually surprised that this isn't
yeah. I guess that would only work when it's a small network because or I guess when you specifically decide to copy in notebook the network, which in general they are a little bit big. You don't want to do that.
Right, but okay, but let's just go back.
Still, I don't think it's a terrible idea because you have a lot of loss functions where you play, and NetFunction will really shine with them. And maybe you want to do a +1 and then becomes +2. You want to try different things.
Exactly. That's what I'm saying. That unlike, I mean, my understanding of this workflow is unlike the case of NetGraph, where only on those rare special occasions do you actually edit it directly. Yeah, Ethan is asking, will this have the same problem as with element-wise layer where only a few things work inside it? Well, that's what you're claiming, is that you can do the general, so long as the compiler can handle it, you can do it. But of course, that relies on the fact that the compiler is working quickly and things.
Yeah.
And I think it's important that you plug this into Christopher's new, compiler calling framework.
But I would be curious to see what is not supported that is useful, because for me, like the coverage has improved in the last. I'm always improving it, and Now I see nothing.
Okay, so Ethan mentions graphs
Yeah,
or ND solve, right?
No, I mean, if the guy who is commenting could say what is not working in the element-wise layer
No,
that
ND
he would
solve.
like to have.
Oh, okay, but
Yeah.
ND
ND
solve is not
solve.
going to work.
Oh, yeah, but
it's going to be tough.
yeah. Okay, I see. ND solve. Yeah.
Yeah,
Right.
that's totally requires a callback into the kernel
Yeah.
because
Yeah, that's
we're
going to require a
implement the
callback.
kernel. Yeah.
But the question is, do we have the plumbing to do a callback?
Yeah, that's what Matthew was working on with compiled layer. And
So the compiled layer uses the compiler's plumbing to do the callback, correct?
Yes. There's still the problem of automatic differentiation that is being worked on. So in the first version, we haven't had our meeting about compiled layer, but in our first version, basically you will have to specify the backward pass, the gradient sort of. And
Yes.
Depending on how advanced is the work that Rob Knapp is doing on automatic differentiation, you might not have to do that for most cases.
Right.
I doubt that ND solve will be automatically differentiable, but
No, that's very, very, very hard.
Yeah.
Although there are presumably numerical ways to do automatic differentiation, which, on the fly, so to speak, that could work. I don't really understand that. I mean, if you have a parameter in the ND solve and you want to differentiate with respect to it on the fly, I'm sure that's possible. It's just not so easy.
Mm-hmm. Okay, so the thing to decide, maybe if you go on top, they're not super exciting things, but so there's this net array thing that has to be introduced to represent an array, but that is learnable. So you can specify its shape. Net array first argument will be the shape. Net array 3, 4 in a list will be something of shape 3, 4. You could also specify some values, net array 3, 4, and you actually put an array. That's the current values. And
the name is not good because basically array, the function, is a thing that generates an array of specified shape.
Yes.
Right, from a function. So, I mean, I could imagine something maybe where it says, net array automatic, shape. See what I'm saying? To represent an array that has no content yet, but, has shape, but not, whatever, form, but not function. It's got a shape, but it doesn't have any content yet.
Yeah.
Making sense. But otherwise, I don't really like I mean, which functions? I mean, it's been a bit random. Which functions are trainable and which functions are not, right? Do you understand what I'm saying?
Yes, basically, it's only the layers that are trainable of the language, and or something you construct with this thing, whatever we call it, which can be like learnable. Unfortunately, we call that array. Usually, people call that weights.
Where do we call that array?
I don't know why the decision was made.
Well, where's it called array?
People call it weights for multiplicative weights.
I'm sorry. Where do we call it array? Where?
So either in the documentation and also in the layer panels, like if you do linear layer.
I don't care about those. And the function names, where are we using array?
In symbol names.
Yes, where are we using?
So we have examples on your screen. Constant layer array.
Constant array layer, yeah. They want to rename, by the way, that's the next point. Because we think it's a bad name. This is
to rename it to array layer. So this is a typical example of array in the name of a symbol.
Oh yeah, but we don't have it yet, do we?
No.
Right, so we don't have to discuss it because
we
don't even have it.
No, sorry, we have constant array layer.
We have constant array layer already.
I understand. Do we have any other array layer?
Net shared array. Look,
yes,
on top right
here.
Net shared array. This thing to share the weights, basically the array. And
okay, so net shared array is something very similar to what you're now proposing to call net array. Right?
No.
Yes. It's an array. It's some kind of weird array object that lives in the neural net framework.
Well, net shared array is basically an inherent wrapper to represent that some array is shared between more layers. So it's
but it's very similar actually,
specific.
to net array. Yeah, it's super similar. It's the symbolic representation of an array.
Yeah, you're right.
Exactly.
You're right. You're right. You're right. You're right.
Well, but okay,
it's shared or not, but no, it's exactly the same. In
Not
one
really,
case,
because
it's shared. And,
no, it is the same. Look at the documentation, Matteo.
when you do net shared array, you can only specify a name, which is purely symbolic. If you do array layer or constant,
we understand. We understand, but it's very much the
represent
same
an array.
idea.
It represents an array. Yes. It's not a layer. It's not whatever. It's an array.
but in one way, you have a specific array well-defined with numbers inside it, while with net shared array, you don't have that. It's just a reference to something.
Not necessarily. Sometimes it's just a shape.
Guys, I'm going to have to go very soon here. So we probably have to reschedule this to continue. I think that... I
mean, since we have net shared array, it makes even more sense to call it net array.
But I don't think either of those names is right. I think we need to rethink the way that this notion of an object. Okay, look, an object that basically is passed around and has its innards reconstituted by training. That's basically what we're talking about here, right?
Mm-hmm.
And that's something that, we need to understand which things have that property. In other words, I'm confused by the semantics of this. And I'm confused by, if you put a net array into a net function and then you get the net function back out again, has the net array been updated or not? Or when has it been updated? When can you edit the code? When it's an opaque net array that has been changed, not changed, etc. I think it's somewhat
updated, yeah.
What's that?
I think it's updated, yes. And it would work if you do a basic operation on net array, it would work. I mean, there's two possibilities. Either it evaluates or it does not. When you actually do net array and put stuff in it, it could evaluate to an array, or it could stay as a net array.
No, I don't think it should evaluate to an array. I think that would be a mistake. I think it wants to be but I think it wants to be a thing that, like a sparse array, just sits there, and you can poke at it and do things to it, and it returns another net array. Right? You say net array, you train the net array, it returns another net array.
Mm-hmm.
Am I making sense? Just like, think about it like a sparse array. And maybe that's the way we should think about this. That it's got, a sparse array is something which has some kind of complicated content and a shape, basically.
Yeah,
and this is the same type of thing.
I like that. I hope implementation-wise, it won't be too hard to make everything works with that, but otherwise I like this design.
Right. So then that way it would if it used that as the pattern, and then I would be more game for the net array name, right? It would look something like that. It would be a net array with some, that type of thing.
Yeah.
And and so what then it is, it's just an array. I mean, it's a little bit unclear to me why it isn't just something like a sparse array. What special features does it have other than that it is trainable when inside a training system?
Because
that's the difference. You just
specify it.
I'm sorry, what are you saying?
Can you do a sparse array of missing? Not really. You see what I mean? Like, you don't have to specify it. You can just say it's something of this size. And but one thing I should mention is that we might need this in other places later. So maybe a more generic name would be great.
Well, I mean, we need to understand exactly what the semantics are. This is an array where its values are being updated somehow externally. I mean, every array has that property. Every array where we give it input, you feed it to a matrix function, it comes back with something else.
Mm-hmm.
Ethan is complaining that the compiler doesn't work with image or image 3D. This is probably the wrong group to talk about that with, but I know that's a I mean, that's certainly, people are aware of that. Will NetFunction work for writing custom layers and losses? Should do, right? Isn't that the point?
Yes. I mean, it's along with a compiled layer.
Hey, look, I have to.
Okay. Maybe just constant array layer, because that's something that we've been.
Okay, if you want to discuss it, you're going to have to wait a couple of minutes, because
Yeah.
I need to.
No,
Okay, why don't
talk
you
later,
talk among yourselves? I'll be back in a couple of minutes. Okay.
Okay. Yeah, I was thinking maybe we would use something like net array, like if we do probabilistic programming or something like that. You know, sometimes you have to define these are our parameters. That's kind of what we're deciding is the parameters of the model.
But is it a wrapper that we need?
Well,
In the cases that you're thinking of, is it something around an array? Or?
It should be something very similar. You know, I say A equal net array or blah, 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 you know, and it's a way so that inside the code we specify that A is a learnable parameter. I mean, or learnable array rather. And having a net here would be a bit weird, but we can always supersede after. If it happens that, you know, we use it in a bunch of other places, we change the name, and here we go. And we deprecate the old one. That would still work. So maybe it's a non-problem for now. Because it would be called like, you know, parameter, you know, like learnable, I don't know. How would we call that? Learnable array, parametric array. And you already put that in the system, by the way. Sorry, I'm changing conversation. Constant array layer to array layer.
Yes, like
you already did a change, right?
Yes.
Yeah, so we should.
Well, for me, we already discussed it during weekly meeting, but that's the thing that I said that what is messy is not like Devin is doing a great job into doing notes, but I don't know, using something like Twiki or Redmine to, you know, to have an architect, yeah, something where you have a project and you click and you can see many times what was decided. Because it happens many times that some of us didn't get that something was decided, and you understand it.
I must say I don't remember, but
for
if
me,
you remember that,
I'm a fan of Redmine. I like Twiki, and I know that some people don't like Twiki. So okay, let's give up Twiki, but Redmine, if we could work with this tool, like no, but honestly, you can organize your project like yeah, you are. Yeah.
I could suggest the dreaded J word, Jira.
No, but Devin, you have to convince all people in the team to use it.
Yeah,
that's the only way to, because otherwise, because we have many tools. We have what was the name of the tool?
Asana.
Asana, yeah. Exactly.
I mean, look, I believe you. If you say that Stephen approved that, you approve that, and let's move on. They were bad name. Array layer, much better. Array times layer, array plus layer.
The thing is that we wanted to remove the constant, but at this meeting, I have the feeling that Stephen wants to. Yeah, he's not happy about array, right? That we started to propagate everywhere. No, we say tensor maybe sometimes. But
do we?
What does he want to say?
I don't know. No.
Because weights is not good. Weights is for multiplicative. So for me, it's a free parameters. It's how I call them.
That's
It's the
true. That's
only
true.
real word that I know for them.
There might not be something better. Yeah, normally it's parameters.
Or learnable parameters, because
A learnable parameter layer, you know, that's bad. Learnable parameter times layer. Yeah, we have to keep array.
Hi guys, solved everything?
Yes.
Okay.
We think we have to keep this array thing because it's really like weight is not even the right thing, because you have weight biases. Like weight is usually used only for the multiplicative parameters. So parameters is actually, or learnable parameter is the right thing, but you know.
For what?
So for example, we're discussing about constant array layer, constant times layer, constant plus layer, which we believe are very bad names. So we want to change them.
Well, especially if they're
array
not
layer,
constant.
array
Is
times
that
layer.
correct? Are they
Exactly,
learnable?
Are not constant. The array, they are learnable. Exactly.
What's the difference between those layers and the
actually,
array layer? Net array, rather.
Yes, exactly. So the difference is that one is a layer and the other one is not a layer. So a layer, you have to give an input.
Sorry, Jen, another viewpoint is that you can still see those as layers. In fact, it's called constant array layer as of now. And it's just a layer that doesn't take any input. So that is why it was called constant, which I don't personally like, but was not completely meaningless.
Yeah.
The
difference with net array.
Yeah.
The difference with net array is that net array, if it's defined, net array, of blah, blah, plus 3 will work. Whereas array layer, we'll have to do array layer, open bracket, close bracket, plus 3. You see what I mean?
Mm-hmm.
It's a layer, so it takes an input, in that case, empty, and then returns something. It will return the array. So array layer, yeah, you give open bracket.
Array layer is a function, which takes things.
Yes.
Right. Whereas
exactly,
net array is just a thing which can be used inside NetFunction that is just represents an array.
Exactly. Actually, at first,
in principle, again, constant times layer and constant plus layer, you could say that they are just sugar. If you have net array, they are just sugar for a function, like a threading layer of input plus net
that's
array.
true. Yes,
or input
that's
times
true.
Net array.
Yeah. Maybe we'll deprecate them. Actually, it's written deprecated or array times layer, deprecated or array. So that's exactly because of your point. If we have net array, we can deprecate constant times and constant plus.
Fine. Okay, so constant array layer just becomes a thing that is a function version. I don't understand why we need it. I mean, it's basically net function net array, isn't it?
Yes.
What's the
I think so. Yes.
What
net array? But
what specifically is it? I mean, net function takes a function. Okay, so what it would be specifically is net function of net array, blah blah blah, ampersand, right? That's what it is, isn't it?
Yes.
Okay. I mean, the question of whether we have a separate function with that name seems, a different issue. But I think if that's what it is it should be called net array layer, because it is a net array, which is just operating as a layer.
Yeah.
I mean, if net array is a thing, then this is just the layered version of that.
Yeah. I agree.
But do we really need it if we have a net function? Can we drop all this business and just keep net array? And
probably not. Probably we don't need it. But if we do need it, it should be net array layer. We may need it for just things to look elegant.
Yeah.
Okay.
Yeah. When people code, people use it because that's kind of a way to do custom, not truly custom, but somewhat custom layer. So it's used.
Okay, there's some comments on our live stream here. A net function for Torch users tutorial. can't comment on that, but it's
Yeah.
okay. Examples of Onyx import to NetFunction. That's a would Onyx import to NetFunction or Onyx imports? How would that work? I thought
Well,
Onyx imported to our layer structure.
Well, so what will happen is that if we encounter an Onyx operator which needs NetFunction in order to be expressed in the framework, then of course it will. As of now, we support, like in 12.2, we will support around, I think it was like 70 or 80 Onyx operators, and none of them is using NetFunction right now. But I mean, if we need it, of course, we'll do it.
Question here about optimizing models and whether they fit in the cache. I think that's at the lower level question of whether things fit in L1 caches and so on is not something we are handling. That's something that's at the MXNet layer.
Maybe not even MXNet, like when you're speaking of CPU caches. Maybe, optimized math backends that MXNet uses, such as, Intel MKL or the new library DNNL, then that stuff, is where you deal with this super, super low level optimization. But I don't think, not even MXNet developers deal with that. Yeah.
Listen, I'm going to have to go because I think, at least, unless I'm not getting reminders about, I thought I was supposed to go to an event in 1 minute. So I think I better just check, unless I was mistaken here. Hold on 1 second. No, I'm not mistaken. I need to go, unfortunately. So we're making some progress, but we'll need to meet again.
Yeah.
Okay. Thanks, guys.